So our last project for day one of the showcase this year also is looking at the role of simulation systems in design, but takes a very different, I think, a very different take on it, asking different questions and coming to a different series of answers. One of the things that we've been researching quite with some detail in the program this year was a shift in a shift in the structure of urban scale AI systems from an emphasis on the processing capacities of particular systems to the sensing capacities of those systems. And to a certain degree, as the processing hardware gets cheaper and smaller and faster, the difference between how a system thinks and what a system is capable of comes down to what it's capable of sensing. And so the simulation is not just a simulation of the information processing, it's a simulation of its inputs and outputs. Altai is another project in which we'll see a blending of synthetic and natural intelligences, of organic and inorganic intelligence, of carbon and non-carbon based sensing and processing into various dynamic recursive systems, by which the search simulations and search vectors within biological systems become so entangled with the search vectors within the synthetic algorithmic systems that it's impossible to disentangle their coevolution with one another. Part of that coevolution is it becomes the disclosure and acceleration of different kinds of adaptive and co-adaptive agencies and behavior. Among them, display, camouflage, showing and not showing, triggering and not triggering. And a hint towards, as well, the urban scale adaptations and precedents for this. For example, how QR codes have appeared as a kind of environmental evolutionary response to the presence of handheld cameras. The ways in which images and machine-readable images become not only mechanisms by which systems represent themselves and simulate themselves, they in fact become operations and devices within those systems on their own part. So with that, it's my pleasure to wrap up our first evening with Altai.
Hello, my name is Qiao. I'm a programmer from Berlin.
Hi, my name is Paul. I'm a designer from Berlin.
Hello, my name is Daria Stupina. I'm an architect based in Moscow.
Hey, my name is Lukáš, Likavčan, and I'm a philosopher from Slovakia. And what you're going to see now, in a short while, is a simulation called Altai. It's an agent-based simulation which is inspired by rich aesthetics, cultural practices, and ecologies which come from a remote mountain region of Altai. This region is on crossroads between 4 countries: China, Russia, Mongolia, and Kazakhstan. And the simulation itself is set in scenario of automated landscape, where biological species, machines, and environments interact to produce unforeseeable visual outputs. Let us unpack now at the beginning the conceptual motivations behind building this simulation. First, at the moment, we are facing an emergence of automated landscapes. It's a dramatic change in the composition of Earth's landscape, in the sense that we humans are slowly obsolete in cities, in countrysides, in logistical hubs, in ports, for example, or in the industrial parks or whatever. We can presume that this kind of change will soon hit also remote regions, such as pristine valleys or mountain systems. And there are certain design challenges we face in automated landscapes. First design challenge is the challenge of how to design address and identity layers for these automated landscapes. And there's a certain unsettling similarity between the kind of ontology which might be instrumental in building these address layers and the ontology of animism. Animism understood as a kind of ontology where each entity, whatever it is on the same par, shares the same generic space, and these entities differ between each other only in terms of their bodily appearance, of their corporeal or physical body. Secondly, how to design machine-to-machine interactions in these automated landscapes. Let us look at one specific example, and that's the example of authentication. What we usually mean by authentication is a kind of process where we check, or some entity checks some specific imprint or a unique footprint of an entity, meaning that this footprint is, for example, what the agent has, what the agent knows, or what the agent is or does. Now, can we use images to encode these behaviors? Can we use images to make them basically work as a kind of instrument for authentication? Well, at the moment, we have, for example, QR codes that work this way. They work as operational images. What are operational images? They are not representation of some process. They are this process themselves. They are the machine that facilitates this process. Before we move to the simulation itself, let me unpack the other conceptual motivations. Here now we are in Russia. And Russia historically is a country that was governed from one node, either St. Petersburg or Moscow. And the governors here were using models, maps, or simulations to actually see this territory as a governable wall. But what if we bracket off the territory and we are left with the model itself? Can there be some space of sovereignty in the simulation itself? What I understand by simulation is a kind of model. A model is a mapping that ignores some traits of the entity while it makes other traits of the entity pronounced, or a territory. And specifically, simulations are also kinds of models which are dynamic, which are complex, and which are closed systems. So imagine them as a little petri dishes, for example. Agent-based simulations are kinds of simulations where agents spontaneously interact between each other. They are good in modeling one specific kind of phenomena, and that's emergence. Emergence is what occurs in complex adaptive systems. Complex adaptive systems are systems where these agents have different sort of evolutionary strategies they use to adapt to each other. And these evolutionary strategies can be viewed as a kind of signaling games. For example, an orchid mantis mimics an appearance of a flower. Why it does it? It does it because it wants to tease a bee. It signals itself as something else that it really is. And then the bee comes, the mantis grabs the bee and eats it.
So, we are landing now in a particular ecosystem. This is Altai environment. It is a last mountain range in a completely remote conditions. Multiple cultural routes went through this region over the time, leaving layers of history. It is a unified place chopped into 4 slices by borders conditions. These are Russia, China, Mongolia, and Kazakhstan. In our simulation, we have three main components: agents that perform certain rituals in certain environments. And now I will unpack the environments part. We've made a research on conditions and history of this region and extracted 7 layers at different altitudes with specific flora and fauna and cultural footprints. For example, we have glacier and tundra, and they are characterized by certain features in the simulation. Environment provides a model for simulation. It informs spatial locations of agents and influences their behavior. Border conditions are also implemented into the system by providing additional rules for the agents flowing through the simulation. So, environment is represented in 2 ways. One is through the 2D interface of the overall region and as a number of 3D models of specific locations of each of the 7 layers. So, for them we picked notable places such as the highest summit of Altai, Beluga Mountain.
Distilling our research on evolutionary strategies, our agents are built on the vocabulary of both animism, and automation. Our agents share properties of both mechanic and biological properties.
To unfold the visual representation of an agent, we see 2 dimensions encoded into the representation of an agent. On the bottom, you see the taxonomy of a so-called family type. The family type of an agent influences its outer shell, the materiality, and its general form. On the other hand, the actual agent type defines its inner desire, its behavior, and its kind of potential rituals it can perform.
This taxonomy is not an act of reduction, but rather we look at how these attributes can build on top of each other. So let's look at some agents. On the top, you have the recognition flower. It camouflages at the same time that it records its surroundings. Plant-like, machine-like machines. Then we have the isolation, sorry, down here. Then we have the isolation silicon, dwelling in higher altitudes of the glacier. We ask questions of what happens when species collide, and we ask what happens when material starts to have its own agenda. It's not a kind of symbiosis, but exhibiting a tendency with cross-pollination. Then we have rituals. Rituals are defined by rule-based practices that happen at a given time in a specific environmental setting.
And by means of talking about rituals, we want to highlight one thing, and that's a certain relation between practices or actions and an institution of collective memory, in the sense that you can basically bootstrap new practices from this collective memory. And this is basically like the phenomena of emergence I've been talking about at the beginning. So now let's move to the another part about the dramaturgy of the simulation. We have basically 3 stages in which the simulation in each situation unfolds. First, you have a certain metagram. We will unpack in a while what it means. Then you have a scene itself, some 3D representation. And then you have a cosmogram, which is a product of a scene. I will explain now everything. Let's first go to the scene.
So, a quick demo of the scene. As a trans agent performing a passage ritual, border crossing is symbolic in the sense that when one enters the zone of receptions, it receives a packet of data or some sort of state changes that allows us a corporal transformation. This is the data mule.
border crossing. Okay, and at the end of each scene, you get this thing called Cosmogram. Let me remind you, at the beginning I was talking about the operational images, and basically understand Cosmogram as an operational image, as a sort of aestheticized ID of the agent within the scene, within the ritual. Cosmograms are first, thus some kinds of footprints and encodings of the footprints of the agents, and secondly, they are also interface of our simulation. We've been inspired in creating this idea of Cosmogram by our research in icons. What are icons? Icons are first, according, for example, to Charles Sanders Peirce, a kind of signs which are constructed by means of analogy. And secondly, icons are interfaces of mediation of some processing, for example, algorithmic processing. We've been inspired here by our research in the way how icons work in religious practices. They are, for example, images that mediate certain act of worshipping or another kind of ritual. And in a secularized variant, they can be used exactly as this kind of interfaces for algorithmic processing. And on the overall level of the simulation, you have like one big map. The map is called metagram, sorry. And the metagram itself is a kind of general map that shows all the happenings ongoing within the simulation at the given time.
And after this introduction of all of these new notions, just a quick recap of what we learned. On the left side, on the y-axis, you see all of the ingredients that come into play in our simulation: environment, agent, and ritual. On the x-axis, you see the actual visual layers of our simulation: scene, cosmogram, and metagram. And since our simulation is agent-based but ritual-centric, the actual scene, where we can actually witness the ritual, is the most aesthetically detailed one. So it's full of these 3D environments. 3D agents and the rituals are depicted by traces. And as we go on from scene, which leaves kind of an imprint, or like as Lukáš framed it within the notion of operational images, we come to this notion of cosmogram, which then reduces each visual layer to one dimension, and then coming to the metagram, which can be seen as a kind of archive of cosmograms, you land in a further abstraction which then orders as kind of interface to actually access all of the other cosmograms.
So basically, our simulation is a petri dish that grows images, and we will unpack now how this process of growing these images works.
Yeah, we have conceived 4 stages of simulation that work as anchors of evolutionary process. Stage 0 is called fully automated landscape. This is the stage where we have 2 agents, recognition and sensor. They are performing quantification rituals and building spatial model of environment.
Stage 1, nature strikes back. We foresee a kind of calibration, some sort of thermodynamics, tuning. Here is a sense of predator and prey dynamics, establishing cyclical changes, things like the Lorentz attractor or Levy's flight, more organic behaviors.
Stage 2, renaissance of civilization. It is where the first inhabitants, the major part of our agents, appear. They set up social structures, populate and regulate their behavior, building up networks.
And then finally, this is where our imagination hits a limitation. We foresee a kind of new emergence with these co-evolution and co-adaptations.
After setting up all of these stages and the actual variables, we now have a look how the simulation actually works together in terms of rule setting. What we can see here is a organigram, which basically represents all of the rules that are kind of coming into play in this kind of simulation. Starting with the actual environment. The environment in our simulation is an actual actor, so it has events in itself. It can have catastrophes, it can inhabit cyclical resets, but also seasons. In total, we have 7 environment types that Dasha already introduced, and each of these environment types can inhabit certain agent types. We have 9 in total. That were the one we introduced, and they are connected to a certain stage. So each of the agent comes into the simulation at a certain stage, encoded by these white rectangles. Each agent then has also intrinsic as well as extrinsic variables, which defines their behavior as well as their visual appearance, as well as their utility function, how they actually move through the simulation. Each agent then can perform a potential type of ritual. In total, we defined 9 ritual types, which then can be triggered by certain events. We defined 4 trigger types: proximity-based events, event-based events, time-based events, and age-based events. Age in terms of meaning, in terms of the actual age of the agent, which then leads us to a potential possibility of 18 rituals in the first initial state. So, as Qiao already mentioned, basically, this organigram just describes the initial stage that we set up and allows for further evolvement of the actual simulation.
Yep. We will now witness 4 rituals that come out of our system. The first ritual is sensing. It is performed by recognition and couple agents in tundra environment.
Next, we have stage 1, hunting for pleasure. You see a predator agent in the highland forest.
Second stage, influence and trance agents performing baptism in glacier environment.
finally, we have stage 2.2, isolation agent in Highland Prairie, performing dwelling.
So, just to briefly recapitulate now, you should still see these conceptual motivations here. Still, this is a project about identity layers and address layers, which are solved by the kind of platform animism proposed. Secondly, there is still this focus on operational images, which we call cosmograms, and they solve the idea of machine-to-machine interaction in automated landscape, specifically the authentication protocols. And third, the idea of model as a space of sovereignty. We have now a running simulation you can see at our website.